Alright, y'all, continuation of my test 2 study guide. Alright, this here wants me to graph this, so this is square root of x minus 2. So I'm going to make me a little table for my x's and y's, because remember, y is the same thing as f of x, okay? Alright, so I need numbers under here that I can take square roots of when I'm done. So the smallest number I can pick is 2, because 2 minus 2 would make that a 0. So I'm going to pick a 2. And I got a 0 when I put a 2 in for the x. And the square root of 0 was 0. Now I want this to equal 1 under there, because I can take the square root of 1. So to do that, I'm going to pick a 3 for my x. 3 minus 2 is 1. Square root of 1 is 1. Alright, so the next perfect square would be 4. So to make this equal a 4 under here, I'm going to make that x a 6. 6 minus 2 is 4. Square root of 4 is 2. Alright, I got 3 numbers, which is probably enough. So I got 2, 0. So go right 2 and put your first point. Then I got 3, 1. So go right 3 and up 1. Then I got 6, 2. So go right 6, up 2. So it sort of goes through like that. If you notice, the only one that does that down here is C. Final answer. Alright, 17 wants to know where this thing is increasing, decreasing, and constant. And we're going to treat it like these arrows are going on forever and ever, okay? So I'm going to find my increasing, then my decreasing, then my constant. So it's increasing from this part right here going uphill. So I need to see what that x value is there. Okay, so that looks like what? 1, 2, 3, 4 on the x's. So it's going to start with a parentheses and a 4. And this graph keeps going forever that way. As I keep going out the x's, it keeps going. So right, it's headed off towards infinity. Alright, reading the graph left to right, this part's going downhill. So what I want to know is, what's this point where it's ending at, right in here. So that looks like what, a negative 1, 2, 3, negative 4. But remember, negative 4 is where that one actually ends at. Where is it coming in from as you go left on these x's? Right, it's coming in from negative infinity. So since negative infinity are smaller than negative 4, it's got to be first when you write these intervals. They got to go left to right. Alright, so look at this. It's constant where it goes straight. And I got these two places already marked off where it changes. And I know their points is going to be, what, a negative 4 for that x. And then this was a positive 4 for that x. Remember, we don't care about these y values when we're looking at the intervals. We just want to know the x values that those happened at, okay? Alright, let's see. Number 18, they're giving me a piecewise function, and they want me to find the specified function value. So what we want to do, we got an f of 8 here. We need to figure out where that 8 fits in one of these 3 domains. So, is 8 less than or equal to 0? No. Is 8 in between a 0 and a 7? No. Is 8 bigger than or equal to 7? Yes, 8 is bigger than 7. So we're going to find f of 8 by using the last equation. Well, f of 8, if you put an 8 in for that x, it tells me f of 8 equals 8. So my final answer would be 8 on that one. Okay, if your replacement value equals your equation, then your answer will equal what your replacement value was, okay? Alright, so here's the fun one. Difference quotient. They're giving me 3x squared plus 3x. So first, I need to find f of x plus h. So to find f of x plus h, I take that equation, and where they got an x, I put x plus h, and then I got a 3. They got an x, so I got to put an x plus h. Now don't worry, we'll use this stuff again later in the formula, but right now we need to find that f of x plus h part of this. So what we got to do is bring down that 3. Now, we've done FOILed this a lot in class, but x plus h squared equals x plus h times x plus h. And if you FOIL that, you get an x squared plus xh, which is the hx. I'm just putting them in alphabetical order. Then another h times x is the hx, and then h times h is the h squared. Adding like terms, we got x squared plus 1 gave us 2hx's plus h squared. Whew, y'all should get used to that by now because we've only FOILed that a lot. So replace the x plus h squared with that. So you got x squared plus 2hx plus h squared. Then bring down your 3 times your x plus h. So you could have distributed that, but I usually do all my distributing in one step. So if I distribute the 3 here, I get a 3x squared plus 6hx plus 3h squared. Here I'll distribute the 3, so I get a plus 3x plus 3h. Alright, notice, none of these are like terms, right? I have no like terms. So that's going to be my f of x plus h minus my f of x. I'm going to put all that over h. And I'm making my parentheses big so y'all can see this good. So here was f of x plus h, 3x squared plus 6hx plus 3h squared plus 3x plus 3h. F of x they gave us way up here. We got 3x squared plus 3x. All that's over h now. So remember, my next step is to come in and distribute to get rid of these parentheses. So I get 3x squared plus 6hx plus 3h squared plus 3x plus 3h. All those signs stayed the same. These are going to be the ones that changes because minus 3x squared minus 3x all over h. Alright, so watch what cancels. This negative 3x squared cancels with that positive 3x squared. Negative 3x cancels with 3x. After this step, all the terms that don't have an h in them have to cancel out up here, okay? So now what's left? 6hx plus 3h squared plus a 3h. All that's over h. See, everything has to have an h left, so when you divide the h's, the bottom h is going to cancel out with everything. Watch this. You got to cancel this h with that h, so that leaves me a 6x plus 3. Here you got an h squared. You got to cancel one of these h squareds with that h, which leaves you a single h. Plus, you got to cancel this h with that h. When you cancel that h with that h, it's gone, and all that's left is the 3. So my final answer would be 6x plus 3h plus 3. So you see the patterns in these once you get going. Like at this step, I knew everything that didn't have an h in it was going to cancel. So that means that 3x was going to go and that 3x squared no matter what. And then my final answer would be actually based on all the h terms in that. Alright, y'all, so that was 19. That's a really fun one, right? Alright, number 20, didn't want this one to be too bad, you know. So, it's got the graph drawn. And it already shows you the point we're looking at. And by looking at that, a minimum is a valley, a maximum is a peak. Well, I got a valley, so I got a minimum for sure. So you can cancel out those maximum answers. Now let's find what this point is. It's going to be a point. So look, this goes over 1, 2. So they're going by 2. So this point must be 3. So my x value is going to be 3. And looks like my y value is going to be a negative 2. So now that I know the points, this has a minimum of negative 2. Remember, the y value is always the min or max value. It has a min of negative 2 at the x equals 3. So let's see. Minimum, negative 2 at x equals 3 looks good. See what they did here. they did minimum of 3 at y equals -2. No, it's always at the x value where the min or max occurs, and the y value is always that min or max value. So on that, and what I say, relative to minimum -2 at x equals 3, so I would go with C on that one. So y'all, don't hurt, play with this a little bit, and just, you'll get good at this, and good luck.